Hi, this is G once again with another tutorial for 3D Studio Max. Actually, this tutorial will be in two parts, and this is the first part which we concentrate on scripting in 3D Studio Max. Not boring scripting, but very useful scripting. Recently I uploaded this video, which is a DNA that gets formed. So we want to create these effects. We will divide the whole tutorial in two sections. The first is how we create the DNA as a modeling object, and the second is how we convert all the modeling to the particles and make the movements. So the first part will be to creating this modeling in with scripting in 3D Studio Max. So for this reason, we open 3D Studio Max, and the first step is to create a helix. I come to here and helix. I create always a helix, and after that I adjust the parameters. So I bring it to 0, 0, 0 positions, and let me save this. Save my work. Okay. And the first radius will be 60, and the second radius also 60, and the height will be 2000. And you can see that it's a long helix, and we have to adjust the turn. I have to put here 6.215. 6.215. 6.215. There are some times that didn't work. 6.21. Okay, that is the terms that we have. The next step will be to create a box, or also you can create a cylinder, no problem. And this cylinder we will apply 50 for radius, 3000 for height, and 140 for the segments, and the side will be 4. So you say each side is 4, you can also create a box. Yeah, you're right, you can do the same, but here with the smooth you have smooth. But you know what, after that we will hide this object, so we don't need it after that. The next step is to apply FFD 3x3x3, and go to the control setting, and what I want to do, I select the control points in the middle, okay, and I try to push them a little bit down, just something like this. So, and I will explain it to you why I am doing this. The next step is to apply a path deform, not patch deform. Okay, pick path. This is my path, and move to path. So you can see that right now we have our object here, and just let me show you with and without FFT. The goal is this: we will create some spheres or balls here on the center of the vertices, and some smaller spheres in the middle of the faces. And the spheres on the vertices, there are red ones, the bigger ones, and the spheres that are in the middle of the faces, they are with some offsets in the Z position, and they are smaller and more wide. So this is our base object. I named this to base, and right click here and say collapse to. Yes, so right now I have editable mesh. We can also convert it to editable poly, because all the scripting that we want to do is based on editable poly. Okay, then the next step is to create two spheres. I create two small spheres, sphere 1, sphere 2, and I can also delete the one of them. And here I make it red, and I name this red strand. Red strand, enter, and this I make the seconds 4 or not. Okay, 6 shouldn't be smooth, and the radius will be 9. Okay, this is the bigger one, and I make a copy, and the other one is a red strand. This is white strand. Okay, and this white strand has another wire color and also a smaller value, 4.5. So these are our two spheres that should be come here on the vertices and on the face. So, but how can we do this? So we can do this very easily with scripting. For this, I create a new script. This is the end result. As you can see, this is what we want to create, and this is our script right now. Before continuing, I select both of them, right click, and OK, and no problem. I think it's okay. Okay, the first thing is to create 3 variables that we have to work with. So I say define variable definition. Okay, the first variable is the body object, which is our the body object. This is our body object. I select it, base. Okay, just come here and make a $sign and base. So this is my body object. The next variable is object to copy red, object to copy red, and this will be my red strand. I copy this here, make here, and the next is object to copy white. and this will be my white strand. Okay, after declaring our main variables, we can begin with our work. Okay, the first thing is that we get the number of vertices. So I create another variable, num of vertex. So this is my variable, and we select here body object, which is this, which is our main object, dot num verts. So we have right now the number of vertices here, okay, and number of vertices, we put it in number of vert. So right now I create a loop for I equal to 1 to I equal to number of vertex do. So what we want to do here, open parentheses and close it. What we want to do here, we want to copy temp object. I create a variable temp object, and this temp object here we want to copy all the red one. Okay, this is the red process. So we in this loop for each vertex we this loop is for each vertices, and we create a new instance of the red strand and put it in the temp object. So after creating this, we have to position it. Okay, so position. So how we can do this, I create another variable, current vertex position, and this current vertex position is this poly operation. Poly operation is an operation of polygon that we have access to many functions in scripting. Poly operation dot get vertex. You see it's getting blue, it means it's a function. Getting vertex from body object. Which vertex? The I vertex. This function of poly operation get the position of an object of an vertex and pass it here. The result is the position of each vertex. So we have right now the position of each vertex, and the next step is to apply this position to our object. So temp object dot position is equal to current vertex position. So so easy is this. And the next thing that we want to do, we want to say wire color, and we want to apply equal color to all of them, and the wire color will be temp object dot wire color is equal to color, and I put just one number, it's nothing special, 135.6.6. So this is a loop that we created. I can come here and right here red strand and make a copy of all of this and paste it here, and this will be the white strand. But here we don't have to work with a number of vertices. What we wanna get is the number of faces. So I create another variable, number of faces is equal to poly operation dot get number faces. Get number faces of body object. So we get the number of faces here, and we say for I2, instead of number of vertices here, number of faces. So here we create another copy, but this copy will be from the white one. So I copy and paste it here. Temporary object is this, and we get here the position is, it's not no more vertex position, so it's very important here. So we have current face position of current vertex position here. We say current face position, and in the current face position, poly operation get face center. So it's another, this is another function that get the face center of the object I and pass it here in the current face position, and we pass this current face position to the temporary object positions. And the wire color, we change the wire color also here. It will be 166 and 229 and 229. So this is the base. We can also save this. Okay, to script. Okay, so what we did here until now, we created three variables for our base, and our red and our blue strand spheres. In the first one, we get the number of vertices with the function number of vertex, and we create a loop and copy the red ones and position it to the position of the vertices. And for the white one, we did the same operation but with the face, with the faces. So we should see if it's work or not. So it was to script. I double click and voila. So you can see here, I had two of these things here. This is why it's happened. So base, I had this. Oh, I have this is because I had it before. So let me delete this and do it once again and hide all. Oh, something that I have forgot. Okay, this is the one that I created before. This is just one side of the space. You know what I mean? So for this, I forgot to make a copy 180 degree. Right now it's okay because I created just one side of the base. So, and I select one of them and attach the other one. So this is the final with that. So I'll save it once again and name it right, base, and hope it that work once again. Go to script. you can see right now that it's working right now, but there are two main problems. The first problem is this, that I have an object which is not sphere or round, so, and you have an object here. If you want to have it so, it means without any rotation in each single sphere, so, or your single instance object, that it will be okay. But here you can see that all the spheres are looking at the top. I mean, there is no rotation. So it was good if we had somehow the information of the rotation, for example, the normals of this object, so we can apply that rotation to the object. And the second thing is this, in my final result, the white ones, they are smaller, so, and I want to have them to, I want to push them here a little bit, having some offset here. So I can do this only if I have rotated in the right position, so I can do this in the local axis and move it so with some offset. So there are too many reasons why we need the rotation. I mean, okay, if I hide this and hide these two also, so what I want to do is I'll select Control A and delete all this and unhide all. Okay, if instead of having 6 segments, I should have 32 segments with smooth one, and here also 32 segments with smooth ones, and apply it once again the script. Okay. You can see that it's looking fine, because you cannot see the direction of, because there are spheres, but still you cannot apply the transform and the offset of this smaller, or the white or the blue ones. So that's why we need to apply the right rotation. And what is the right rotation? Okay, here what we want to do, we get the normals of the faces and of the vertices and apply it as a rotation to our objects. So this will be our next task. But before going further, I should tell you something. If we work with mesh object instead of poly, there were some more functions, but in the poly operation there is no function for getting the normal of the vertices. So that's why I will say that it's complex, not complex, but a little bit more complicated task. So that's why we first begin. We first will do this with the white one, which is the faces, and then jump to the red strand. So, but for the right strand, for the white strand. Okay, the first thing that we want to do is we have to get the normals of the before applying the positions. Sorry. So what we need here right now is apply the right rotation. Okay, apply the right rotation. So for this, first we get the face normal, and the face normal will be the poly operation, or poly operation dot get face normal from the body object I. So we get the face normal. There is a function for getting the face normal, and after we get the face normal, we have to apply it, and this process of applying this face normal, it's a little, not too much, a little bit complicated. We create first a vector, and we name it world up vector, and this vector will be 0, 0, 1 vector. Okay, after this we create another one, which is right vector. Right vector is another vector that we create here, and this right vector will be the cross product of the world vector and our face normal. And after we do this cross product, we will normalize it. So I begin from the from normalize. So I will write normalize. What should we normalize? Actually, we will normalize the cross product of the world up vector. I copy it here, and the face normal. So we cross product the two of this and close the bracket. This is for the normalize, and we put it to the right vector. After we normalize the cross product of these two, we create another variable. I copy this and change the name after that. The next one will be our up vector. Up vector. The up vector is normalized from the right vector actually, and the face normal. So we get the up vector from here, and after this, what we want to do, we create a matrix. I will say another variable, the matrix, and this matrix will be a matrix 3. This will be the combination of the right vector, the up vector, and the right vector, the up vector, and the face normal, and last 0, 0, 0. So what we did here, we okay, let me just put this to the end and explain it after that. The last step is to say that we have our temp object, and this temp object that transform is equal to the matrix that we have. So why we did all this complex process? This is because each object in the 3D Studio Max has a transform matrix, which is a 4×4 matrix, and if you want to just apply a position, it will be easy, because position it's very simple task, but for rotating an object it's somehow more difficult, and it's better that to apply it to the transform of the object. The transform of the object is the matrix of the object. And what we did here right now, we first apply the rotation in the origin, in the 0. So we don't care about the position of the object until we apply the rotation of the object. So how we do this, calculate this rotation? We have a face normal, we create an up vector, and we get a cross product. The cross product is a perpendicular it's a perpendicular vector to both these two vectors. So we get a third vector, which is the right vector, and we cross product it once again with the face normal, which we get an up vector. And after that we create a matrix which included all these three vectors, and we get the matrix for the rotation, and we apply this matrix of the rotation to our object. And after we did this process, we after that we just transform it in the positions. So I hope that you understand it. It may be good that we have a special tutorial just for this part. So if this part is somehow complex to you, just feel free to ask me or tell me that we can do another, because it's a simple task in mathematics. That's all. Okay, I save this, and we want to see if it works or not. So I bring it back to 6 so I can see what I'm doing. Okay, and I save this here too, and run script and to script. You can see that right now our that small or the white strands, or the whatever you can call them, the blue ones, the small ones, and they have the right position. So now that they are aligned correctly on my base object, I can easily offset them in the Z position. You can see. So that is the goal. So I hide this here, hide these two, Control A to delete all of this and bring all this back, and come back to my script. So after this, what we want to do is make some offset, and we say offset in Z position. And this offset in the Z position is a very simple one, is in coord system that I explained it to you. Local, the temp object dot pose dot Z is equal to 5.5. What this means, I could just write this one. It means the position of the Z position is plus equal to 5.5, and this plus equal, it means that this value is equal to this value plus the other value. So, and we do this in many scripting, also in C++ and other scripting, so it's not very unusual thing. But the only thing that we have here is in local, in coordinate system local. It is this, because if we don't write this, so we will have the world coordinate system, and our Z and our other axes are wrong one. So right now we say that change it to the local coordinate system and make some offset in the Z position, and we save this. And once again we check this off. You can see that right now it's working. Right now I have all my small spheres in the right rotation and with some offset. So that is wonderful until now. So we are almost done. Don't get tired, just continue with me. If you want to take a break and come back, but we are done. Okay, the last step is to do the same process for the red strand, but the problem is that the red strand are positioned on the vertices, and for the vertices we have not something like this, get the face normal. So what we want to do, what we should do, we have one vertex, we will collect all the faces around these vertices, faces around this vertex. We get the normals of all of the faces, and after we did this, we make an average from them and apply it as our vertex, current vertex normal. So a little bit more complex, but it's still easy to do. So for this, what we want to do is get the face. Okay, instead of talking too much, we should begin. Get the face normals of the surrounding faces and average them by adding them all together. By the way, if you do this one and it gets green, it means that it's not calculating the process of the scripting. It's just for the for the scripter to know what he's doing, because right now you can understand what you are doing, but maybe in 1 month or 2 months or maybe 1 year you should understand what you did in each step of your code. So first we create a variable and we name it vertex faces, and this will be the poly operation, and get faces using vertex. So this is a function, so it will get all the faces around your vertex from the body object, which vertex? The I vertex, the current vertex that we are talking about. And we create another variable which will be dt, it for temporary normal, and we equal this to 0, 0, 0. So the first the normal is 0, 0, 0. And right now we create another loop inside our loop for r, because I usually use I, but we have right now in an I loop, so I choose another something else. It's normal for r in vertex faces, which is this variable. Okay, for r in vertex faces do, and what we should do is okay, here this is another kind of loop. You see, we have here for I equal to 1 to I equal to number of vertices do, but here we have for r in vertex faces. Why it's so? Because this function, this get faces using vertices, this gives you a bit array, and bit array it means it's an array for all the faces, and the faces that are selected, that only the faces that are selected are true. So we say go and see the faces that are selected. For r in vertex faces, what we should do here, we should say temporary normal. This is this variable that we have here is equal to not equal, is plus equal to poly operation dot get face normal of the body object r. So what we want to do here, we calculate just the normals of the faces that are selected here in these vertex faces, and we add it here to our temporary normal. When we are done, we are out of the loop, we have our face normal, and our face normal is equal to normalize, the normalize of temporary normal, and divide by vertex faces, which is this one, dot vertex faces dot number set. So what we have here right now, I hope that this is right. This is the number. For example, we had 4 faces, 5 faces. This is an vertex number set, gives you the number of faces that are around the vertex, and we divide it by the temporary normal and normalize it, and we get our face normal. So once we get our face normal, we can copy all this stuff here and come here after here and apply it here. So after this, just see, so we have right now our face normal. We don't need this function anymore. We create once again another up vector, and both up vector, up vector, matrix, and what I think that's okay right now, and that will work. So I save this, and I hope that it will work. I don't know, you have always to check. And you can see here right now, this is the final result. All the objects are positioned exactly at the normal of the vertices, and the smaller one also. They are in the normal of the faces. I hide this and hide these two all. Control R, delete all of them. Control R once again, because we are on the end of the tutorial. I put as 32 for segment and make it smooth, and another one 32 smooth. Control S for save, and apply it for the last time, and hide this and hide these two, and press H and type an R here to get all the red ones, and here we can type red strands, enter, hide, Control A here, white strands, enter. Okay, and I come here back, I have our red strands, save this, and here voila, you have all your object positions. So this was all what we wanted to explain in this tutorial. A very simple but useful script that let you do some very crazy stuff in 3D Studio Max and for modeling. You can use this technique also in many other things in 3D Studio Max. So it was a long and boring tutorial. I hope that you like this tutorial and you learned something. Once again, if you like my works, don't forget to like and to subscribe. And this is the first part of this tutorial. The second part, you have to wait for the second part, which we will explain how to convert all these shapers, all these objects to the particles, and to play with the particle. It will be some fun, because we will work with data operator and some other stuff like this. So I hope that you like this tutorial and you enjoyed it. Don't forget once again to subscribe. Here's your friends Hamid Ghanbari in a G production. Bye.